Alright, so now we're going to take a look at multiplying and distributing some radicals. Alright, our first example, we have 2 times the square root of 3 times these two terms that are in parentheses. We've got one term here and one term here. So what we're going to do is we're going to distribute 2 square roots of 3 and multiply it by 3 square roots of 6. So what we're going to do is we're going to multiply the like parts. 2 times 3 gives us 6. And then when we multiply the square root of 3 times the square root of 6, our answer goes underneath the square root, and we actually do multiply the 3 times the 6 and get 18. Minus, now we're going to multiply to this radical. Well, we've got this 2 out front, but you can think about there being a 1 out front. 2 times 1 is 2, and then you multiply the radicals, square root of 3 times the square root of 24. Is the square root of 72. Alright, so this would be a great answer. However, now we're looking at a subtraction problem, and so we want to see if we can subtract these two terms. Well, they're not like terms, but like we've been doing, if we can reduce the radical, we'll go ahead and reduce the radical and see if they end up being like terms. So square root of 18, again we're using our square roots, so 4, 9, 16, 25. This reduces to the square root of 9 times the square root of 2. Square root of 9 is 3 times the square root of 2. That 6 comes out front, multiplied by the 3. So we actually have 18 square roots of 2. Bring down your minus sign. Alright, can we reduce the square root of 72? So find that biggest radical that fits in, and 36 fits in twice. Square root of 36 is 6. Square roots of 2, bring down that 2 out front. Multiply, we get 12 square roots of 2. Now we can see that yes, we do actually have like terms because they are both the square root of 2. So we go ahead and subtract the numbers out front, the 18 and the 12. 18 minus 12 is 6, and the square root of 2 stays. Alright, next example, same idea. We're just going to do some distributing, multiply the like parts, and see if we should reduce and combine like terms. Alright, so we multiply this, we multiply the numbers out front. Negative 4 times 3 is negative 12. Then you multiply the radicals. 6 times 2 is 12. Now when we multiply to this one, we see we have a negative 4 times a negative 5. That's going to give us a positive 20. And then when we multiply the radicals, 6 times 3 is 18. So similar to the last example, these are not like terms, but let's see if we can do any reducing and figure out if they end up being like terms. So this breaks down into a 4 and a 3. Square root of 4 is 2 times the square root of 3, and you bring down that negative 12 out front. So we have negative 24 times the square root of 3. Plus, let's see what happens on the next one. This breaks down into square root of 9 times the square root of 2. Square root of 9 is 3. Square roots of 2, bring down your 20, and we have 60 square roots of 2. Can we go ahead and add these together? Well, we take a look at the radicals. That's a square root of 3, that's a square root of 2, and we see that they're not like terms, so this actually is our final answer. Alright, one more example. Oh, this one has some variables, so that'll just make it a little bit more fun, don't you think? Alright, so we're going to do our distributing. Here's a radical times a radical, so we can multiply everything inside. 9 times 2 is 18. X times x is x squared. Multiply to this one, so minus radical times radical. Go ahead and multiply everything. We have 8x to the 5th. Alright, so let's see what happens when we reduce these. We're square rooting an 18 and an x squared, so the 18 we can reduce. 9 and 2, that becomes a 3 square root of 2, but then we're square rooting an x squared, so how many, because it's a square root, we're looking for groups of 2. How many groups of 2 can we get out of x squared? Just 1, so we have just an x out front, none left over underneath the radical. Minus, break down the square root of 8 into square root of 4 square root of 2. That gives us a 2 square root of 2, but now we have to take the square root of x to the 5th. So how many groups of 2 can you get out of x to the 5th? And that's going to give you 2 of them. So x squared goes out front. So because we had 2 groups, or 2 pairs that fits into that, that's why that's x squared. But that only accounts for 4 x's. We do have a leftover x that stays underneath the radical with the 2. So do we have like terms? Here's a square root of 2. This is a square root of 2, but that also has an x. So that means those are not like terms. So this is our final answer.